Okay, so in the last session we talked about exponential equations and different properties of exponentials. Things like if a to the x equals a to the y, then x equals y. And we use that to solve problems. Today we're going to look at something else and we'll kind of define it and then apply some properties like this to set up problems. And essentially the idea is we started this chapter by talking about inverses, and as it turns out, inverses are important. And now we're talking about exponentials. And if exponentials are important, and they're one-to-one, which means they have inverses, then logically their inverses should also be important. So we're going to look at the inverses of exponential equations today, which are called logarithms. If you've ever seen a logarithm, it looks like something like this. This right here is called the base. So this is essentially log base 2 of 8. And as far as the definition goes, we can just say log base a of x equals y means a to the y equals x. And there's our exponential right there. These are inverses, so the inverse of this log is an exponential. Just flip the x and the y, just like you guys did for homework to find inverses. So as far as solving this goes, well, log base 2 of 8 equals x. By definition, that means the base 2 raised to this power equals 8. And then now we can solve. 2 cubed is 8, so x has to equal 3. And we're done. And that's essentially all we really need to know. So really quickly, just to do one or two of them, log base 5 of 125. Well, if that's equal to x, then by definition, that means 5 to the x equals 125. And now, just to use the property from last time, 125 is 5 cubed. So now we have 5 to the x equals 5 cubed, which means x equals 3, and we're done. As far as it goes, we have these logarithms, and we want to be able to solve problems with them in the same way that we were solving exponentials. In order to do that, just like with exponentials, we need a few properties, and then we'll use those to solve problems. I'm not going to bother to prove all these properties out. We could, but that would make this video longer, and we just want to work on using them to solve problems. So, let's see. To kind of run through these, because we're going to use all these properties to solve things, we have our rule for exponentials. If a to the x equals a to the y, then x equals y. We have now the definition of a log. Log base a of x equals y means a to the y equals x. There's actually a similar property for exponentials for logs. If log base a of x equals log base a of y, if you have two logs with the same base that are equal, then just like we canceled out the bases for these exponentials, we can cancel out the logs. And x equals y. That one's pretty straightforward. It's essentially the same as that. It's just from logarithms as opposed to exponentials. So the ones we really use and care about. First one, log base a of mn equals log base a of m plus log base a of n. If you have the log of something that's a product, you can rewrite it as the sum of two logs. In math speak, the log of a product is the sum of the logs. Essentially the idea. If you have log base 3 of x times y squared, that's the log of a product, x times y squared. So we could rewrite it as log base 3 of x plus log base 3 of y squared. Rewrite our log of a product as the sum of two logs. And when we start problem solving, we'll use these things going backwards and forwards to help us solve problems. The next property. Log of a quotient, m over n, is equal to the log of m minus log base a of n. So we just have to keep these straight. The log of a product is the sum of the logs. The log of a quotient is the difference of the logs. So if we had log base 3 of 7 over 5, log of a quotient, that's equal to log base 3 of 7 minus log base 3 of 5. And again, we'll use these to solve problems in a few minutes, maybe in the next video. The last property we'll need, log base a of m to the r. If you have the log of something raised to a power, this power r comes down in front as a constant. And you get r times log base a of m. So, if you have log base 2 of x squared, this power can come down in front as 2 log base 2 of x. So there we have all of our properties, and in this case, for the purposes of right now, these are the important ones. Log of product is sum of logs, log of quotient is difference of logs, log of something raised to a power, power comes down in front. I hope you have these written in your notes, and now we'll, because I have to erase them so we have more room to write problems, and we're just going to use those. And the way this works is, before we actually solve problems, we want to work with the properties to make sure we understand them. So, suppose we have log base 3 of x squared y cubed all over z to the 4th. That's one log. Rewrite it as the sum or difference of several logs with no powers. Essentially, we're not solving problems, we're applying the properties to make sure we understand them. So let's see. First off, this is the log of a quotient, top over bottom. So we can rewrite that, according to our properties, as a log of it, as difference of logs. So that becomes log base 3 of the top, x squared y cubed, minus log base 3 of the bottom, z to the 4th. But now, this is now the log of a product, x squared times y cubed. Other property said log of product is sum of logs. So we can rewrite this as log base 3 of x squared plus log base 3 of y cubed minus log base 3 of z to the 4th. But now we have several different logs, all of them raised to powers. Other property said the powers come down in front. So we can rewrite this as 2 log base 3 of x plus 3 log base 3 of y minus 4 log base 3 of z. And now we've taken this one log and rewritten it as a sum or difference of logs with no powers. Again, I stress, we're not solving problems here. We're just applying the properties to practice them, to make sure we understand them and how they work. You'll do some of this for homework just to get a feel for the properties, because once we start solving problems, we need to have these down by heart so that we can solve the problems. So, one more. Suppose we have 3 log of x plus 2 log of x minus 1 minus 6 log of y. Rewrite that as one log. First off, I will point out these are all just logs. I don't have a base there. You all remember that's common log base 10. But now, use the properties to write that as one log. Well, first, we have constants out in front. Those can be brought in as powers. So this becomes log of x cubed plus log of x minus 1 squared minus log of y to the 6th. But now, this is the sum of two logs. The property says I can write that as the product, log of the product. So it's log of x cubed times x minus 1 squared. You don't need to FOIL that out for right now, just leave it like that. When we get to problem solving, then we'll have to solve all of that. Minus log of y to the 6th. But now this is the difference of two logs. property says the difference of logs is log of the quotient. Log of x cubed, x minus 1 squared, over y to the 6th. And now I've taken several logs and written them as one log using my properties. For practice, you could take this one and go backwards and make sure you end up back here. Use the properties from here and rewrite it as a sum or difference of logs and make sure that's what you get. Like I said, in the next video, we're going to look at a few more logs and then solve some problems and use these properties.